Good morning. Hope everyone's doing well. We have been studying for the longest time what we call Newtonian mechanics, everything to that came from Newton's laws. So, starting from Newton's laws of motion to the law of conservation of momentum, the law of conservation of energy, everything we pretty much did has been based on Newton's laws up till now. And now we move into the world of modern physics where a whole bunch of really strange laws come into effect when things become really, really small or really, really large. And so we'll look at some of those interesting phenomena that is usually quite hidden from us. We'll start up with the four forces of nature. They're called fundamental forces. And you've met two of them already, gravitation and electromagnetism. They both act at a distance without touching each other. They can be pulling or pushing or whatsoever. And we know how that works. And these two are kind of rather not known. And this one called a weak force, and the other one's called a strong force. Again, physicists don't have a whole bunch of talent in coming up with cool names. These four forces, let me just talk about them a little bit. Gravity is the weakest of them all. And you're like, wait, that's the one I can feel the most. And then the weak force, and then the electromagnetic force, and then the strong nuclear. That's the strongest of them all. So, what is the weak force and the strong force? We'll talk about the weak force first. It's kind of interesting. The weak force is a force that is basically responsible for radioactivity. It's what makes things radioactive. And kind of let's see how that happens. In nature, generally, we think of these three particles that make up everything: neutrons, protons, and electrons. And they appear like a neutron will always be a neutron and a proton will always be a proton, but actually that's not quite the case. A neutron sometimes decides he wants to be a proton. Don't like me a neutron anymore. And sometimes it happens that a proton decides he wants to be a neutron. Now, the law of conservation of charge basically says that you can't just create a net positive or negative charge. Out of nowhere. So how does this happen? How does a neutron become into a proton? Well, if a neutron becomes into a proton, that means a neutral starts off with zero charge and then suddenly you have a positive charge. You can't do that. So the neutron actually has to not only just create a proton, but also create an electron at the same time. So he becomes into a proton and releases an electron. And so the law of conservation of charge is conserved because before it was neutral, and now we have one positive, one negative, which is, again, neutral together. And so no net charge was created. Same thing with the proton changing into a neutron. And now you have positive before, now you have zero. So obviously this positive has to end up with another positive on this end. And so it creates what's called an anti-electron, which is positively charged, also known as a positron. And they also, to balance everything out, spins, etc., they also create what's called a neutrino. And we'll talk about neutrinos at another time. They're really cool too. Now, what happens is radioactivity is when these electrons are emitted, which is one kind of thing that happens with the weak force, then the energy of that outcoming electron is the energy that we basically perceive as the energy coming out from radiation or radioactivity. And this particle that comes out is what we call a beta particle. And another name for an electron. Back then, when things happened, they didn't really know what they were seeing with an electron, so they called it a beta particle. And later on realized it was an electron, so the name kind of beta particle stuck. And so now we see that when you have something, and so here's a case of radioactivity, and I'm running out of time on this video, so I will continue in the next one, kind of show you how this isotope of carbon, if you recall what isotopes are the same material, the same element, but has a different number of neutrons. And so it has a different atomic mass, but the same atomic number. And so it's like a variation of an element.